Hello, my name is Mike Geig, and in this video we're going to be looking at inheritance in C#. Now, before I get into the code, I kind of want to talk a little bit about inheritance, namely what it is and things like that. You should have a little bit of familiarity with it at this point. If not, this is going to be a quick review. Now, inheritance can also be called specialization. Basically, it's where we reuse a block of code to make it more specialized. Okay, so for instance, we've used so far class person. All right, that is our representation of a person. Now, if we think about people, all right, one of the things we can often think about is what they do for a living. So I could have a class for, say, like fireman and police officer and lawyer and cook and waiter and all these different things. However, I wouldn't want every fireman, police, waiter, every class to have its own name and age, right? And whatever else we decide all people have in common. Instead, we're going to define the class person as the common ground for all of these different people. And anything they all have in common will go in the person class. For instance, all people have names and ages. Okay, so that's something that we put in the person class. Then, when creating our specialized classes, we don't need to add name and age again. They'll already have it because they will be specialized or inherited from the original person class. And we can go further and further and further with it, and we're going to take a look. What we're going to do is we're going to take an employee, which is basically a person, and then we're going to inherit from that and create two new classes, a salaried employee and an hourly employee, because they kind of do things a little bit differently. All right, so so basically that's kind of why we use inheritance. We specialize, we focus, and we reuse code, so we don't have to keep typing the same things over and over and over again. All right. Now this should look very familiar to you. This says class employee, but it is the person class. All right. So basically just reusing the code from our person class, slapping a new name on it though, and calling it employee. And we are going to call this our base class. All right. Let's say we're making some payroll system or whatever. Our employee is our most basic object. All of the people working for our supposed company are employees. Okay, they might be different types of employees, but they're all employees. So in this class, we put the things that all employees have in common. Now, I'm only doing name and age to keep this example simple, but you could also do like phone number, address, social security number, so on and so forth. All of these things that they all have in common. All right, everyone has a birthday, and everyone has a this and a that, and what first name, a last name, possibly a middle name, a gender, things like that. So that would all go inside this employee class as the base class for everyone who works for our supposed company. But like I said, in this example, we're just doing name and age, keeping it real simple here. Okay. Now, let's go ahead and just run this through and make sure it works. I don't have any data validation, just keeping it real simple right now, but this is all the code we've seen before. In my program, I'm just going to do employee, my employee equals new employee, and we'll do name, Mike, age 20, okay. And then we will do console.writeLine, my employee dot toString. Okay, and I'll run it, and we get my name is Mike and my age is 20. Awesome, great, fantastic. Okay, so that all does well and good. Now let's say I want to add some functionality. Okay, say I'm programming for some company, and now they want me to add a function to this class that will calculate their pay based on some inputs. Okay. Now, right now, that's going to be a little tricky, okay? I could just add a pay method, right? The problem is that what if an employee is a salaried employee versus an hourly employee? Obviously, the pay is going to be different, all right? Hourly employee, it matters how many hours they worked in a week. Salaried employee, it doesn't matter at all, okay? And so we need to kind of figure some stuff out there. We need to kind of extend this. Not only that, but an hourly employee is going to store how much they get paid in terms of how much money per hour. A salaried employee is just going to store their salary. All right, and so we need to obviously do a little bit of calculation here to kind of figure out how we're going to pay them, and it doesn't really make a whole lot of sense to put stuff in here. All right. The way I like to talk about inheritance is to talk about an is-a relationship. What that means is we have to ask ourselves, is one thing another thing? All right. So is an hourly employee an employee? Well, the answer is yes. So we know hourly employee is going to inherit from employee. Is a salaried employee an employee? Well, yes. So we know salaried employee is going to inherit from employee. Now, is an hourly employee a salary employee? And the answer is no. So they're not going to really have anything to do with each other. All right. So they're going to be two separate base classes. And let's go ahead and add one of those now. So I'm going to go back up here to employee test. I'm going to right click, add new item, class, and this is going to be salary employee. Just like that. All right. So now we have a salaried employee. All right. Now, inside this class, you might be asking yourself, well, what goes in here? Do I need to create a name and an age? No, because we are going to inherit salaried employee from employee. And we do that by this. We say class, salaried employee, semicolon, employee. Now, our program knows that our salaried employee is also an employee and will have everything an employee has. So let's test this out. I'm just going to go ahead and save this. And we're going to go ahead and create an object. There's nothing in here. Okay, there's nothing in here. But if I go to my program, let me get rid of this here, and let me say salary employee, my employee, equals new salary employee. All right, now we don't have any custom constructors, so you'll note I can't put anything in there yet. But I can do my employee dot, and look what I have access to. Name. Well, look at that. Oops. And how about my emp age? Look at that there. And then we can do console dot writeline my employee dot toString, and we run it, and we see my name is Mike and my age is 20. So look at this. Everything that we could do with an employee, we can do with a salaried employee. How fantastic is that? I don't have any code in here, yet we get all of this functionality just because we inherited it. We have access to it. Now, while we're talking about access, I do want to mention that the private members of employee, while they exist in our salary employee, are not accessible by our salary employee, right? For instance, in my program here, I still can't do my emp, which is a salary employee, dot lowercase age, because we don't have access to it. It's private. Furthermore, we couldn't access it even in here. It's private. It can only be accessed in employee class. Even classes that inherit it can't use it. The way I like to liken this, the way I like to compare it, is let's say a family member of yours, passes or whatever, and they give you a safe. You inherit a safe, okay, or a lockbox. Just because it's in your house, just because you own it, does not mean you can open it. All right. If you don't have a key, you can't open it. All right. Private members are like that. While a salaried employee will have a name and an age, it cannot access the name and the age. And we do that so that people can't inherit from our classes and bypass our security, our data validation, and our set methods. Otherwise, they would just be able to inherit from our class and then screw everything up. We want the maximum amount of security, and so we prevent them. Even classes that inherit from it or inherit these to be able to access them. So yeah, there's just a quick note there. Just because you have a name and an age does not mean you can access a name and an age. All right, so we're in salaried employee now, so let's go ahead and add some functionality. So let's talk about what makes a salaried employee a salaried employee. So let's talk about their private double salary. All right, that's kind of important, I would think. And we're going to do public double salary. We're going to do our get and set methods here. And we're going to say get return salary and set salary equals value. I'm not going to do any data validation. Try to keep this simple. All right. We are also going to have a public double calculate pay, which is going to return our salary divided by 26. All right, because we assume out of 52 weeks in a year, you get paid every other week, so 26 pay weeks. So we're going to return our yearly salary divided by 26. All right, so that's our calculated pay. All right, and let's go ahead and add ourselves a constructor here because this is important. We're going to add two constructors. We're going to say no argument constructor, and we are going to have an argumented constructor. Plus, I want to have this so you can see how to access the constructors of our base classes. So I'm going to do a public salary employee that takes no arguments, and we'll leave this here for a second. We'll come back to it. I'm going to have a public salary employee that takes in double salary. I would just do L salary like that. And I'm going to have a public salary employee that takes in a string L name, an int L age, and a double L salary. Now, for those of you watching at home, which one do you think is going to be the constructor that actually does the work? All right. If you remember from the previous videos, the constructor that I choose generally to do all the work is the one that takes the maximum number of arguments. In that case, it's this one here. So my salaried employee with no arguments is going to say this, and it's going to pass an empty string, 0 and 0. Oh, I can get rid of those extra. There we go. Just like that. Our salary employee that takes in the salary is going to say this. It's going to pass in empty quotes, 0 and L salary, just like that. And I like to have a space in there. Let me condense this down a little bit. And then of course this one here is going to say, and this is new. All right, we could do this. We could say name equals L name. And no, I can't say lowercase age. I don't have access to it. But I can say age equal to L age. I can say this. This is fine. All right. However, you know, I would choose to use the constructor of the base class just to be sure. You know, who knows what else that constructor does? Let's just make sure we're using it to our utmost efficiency. We can do this. There's no problem with this. But instead, I'm going to say, instead of this, I'm going to say base. And I get to choose my base constructor here. And base is going to take L name and L age. And then in this constructor, we're only going to do things that relate to this class. All right. This class, it's kind of like little modules or Legos or blocks. You know, we're going to let employee handle everything that's important to employee, and we're going to let salary employee handle everything that's important to salary employee. So we're going to let our base constructor just handle that. We don't care. Let them do it. They wrote all that code themselves. Why am I rewriting it? Right. So here, all I'm going to do is I'm going to worry about my own stuff, and I'm going to say salary equals L salary. Easy. Great. Now our constructors are all set up. Every class is only worrying about its own stuff. Salary employee is not worrying about employee, and employee is not worrying about salary employee. They don't even know they exist for a little bit. They're really decoupled. All right. So this looks great. All right. We can test it out. Let's go ahead and test it out here. And let's say, let me rewrite this here. So I'm going to say salary employee, my sal emp equals new salary employee, and I'm going to pass in that my name is Mike, my age is 20, and my salary is going to be, let's say $65,000. Okay. I wish that made that much. Okay. And so then we're going to say console.writeLine, and we're going to say your pay is. Now that I started doing that in these videos, I keep doing it, even though normally I just add them together. And then I'm going to say my Sal employee dot calculate pay. Oops, just like that. And then just for the heck of it, I'm going to do a console dot writeLine my Sal employee dot toString. Okay, so we go ahead and run this, and we're going to see my pay is $2,500. All right, I guess I really could put, here, let me fix this. I can put $, and we can do formatting and stuff, but I'm not worried about it. All right, so my pay is $2,500. My name is Mike. My age is 20. Okay, that looks pretty darn good. Okay, so we have our calculate pay and everything. That's fantastic. All right. So we're going to go ahead and change one more thing with this class before we start working on the next class, and that's this toString method. I don't really like this toString method. All right. The only thing is it's the employee toString method. My name is Mike and my age is whatever. All right. What it's leaving out is what's our salary. Okay. So I'm going to show you how to override this method and add on to it. Okay. So I'm going to come down here into my salary employee class. I'm going to say public string to string. Oops, I forgot the override keyword. Just like this. Let's see here. I got an error. Oh, not all code paths return value. I haven't returned anything yet. So now I could do this. All right, I can do this. My name is, and my age is. Also, I make dollars a year. Oops. And in there we'd put name, age, salary. All right, this works. Let's go ahead and come back here and we'll run it. And we see my name is Mike, my age is 20. Also, I make $65,000 a year. All right. But see, this works. This is fine. There's nothing wrong with this per se. Technically, it's fine. What's the problem here? The problem is, look at this code here, all right? And look at this code here. It's identical. It's the same code. We're remaking it. We're basically typing more than we have to. So I say instead, let's go ahead and return, all right? Let's go ahead and return base.toString. So we're calling the toString method of our parent class plus string.format. Now we'll just say, wait a minute, and we'll just say, also, I make salary dollars a year. All right, and we'll go ahead and run that. And we see my name is Mike, my age is 20, also I make $65,000 a year. So it says pretty much the exact same thing. However, we don't have to retype what's in our base class. All right. And while it wouldn't have been too difficult to retype what was in the base class, consider we have a class that inherits from one class, which in turn inherited from another class, which inherited from another class, which inherited from another class. Do you really want to rewrite your toString methods completely every single time? Isn't it easier just to call the toString method of the class before you and then just tack on your new stuff, your new data? It's much easier to do that. So that's what we're going to do here. All right, so let's go ahead and just save this. And now we can begin working on our next class. All right, we're going to work on our hourly employee. So I'm going to come back up here to employee test. I'm going to go add new item. And this one's going to be our hourly employee. Just like that. Now, hourly employee is going to inherit from employee. So we just do our colon mark there, our double dots in our employee. And this class is only going to worry about having private double rate. All right. It's also going to need a private double hours worked. Okay, so this needs more than just your salary. It needs your rate and your hours worked. And we'll go ahead and we'll create our properties here. So I'll do public double rate get return rate set rate equals value, just like that. Public double hours worked, and we'll do get return hours worked set hours worked equals value, just like that. Fantastic. All right, so we got those. Let's go ahead and write our constructors here. I'm going to do a public hourly employee with no arguments. I'm going to do a public hourly employee with our double L rate and double hours worked. I'm going to show you here. I'm going to do it the way I normally do it right now. I'm going to do rate and hours worked. Okay, they have the same name as these up here. This is going to cause an issue. We're going to fix the issue. Okay, and then and I need to make that double hours worked. All right, just like that. I'm also going to have public. Oh, the reason I don't have a constructor that only takes a rate or only takes an hours worked, I forced the user, if he's going to supply one, or he or she is going to supply the one, they're going to supply the other one too, because one is completely useless without the other one. All right, there's no purpose to reading in only one of those two values. They work in conjunction with each other. All right, and then I'm going to say hourly employee, and this one is going to take string name, int age, double rate, and double hours worked. All right, and that's the one that's going to do all our work. So now that we have that one there, this one is going to say this, and we're going to pass an empty string, a 0, a 0, and a 0. In this one, we are going to say this, and we're going to pass an empty string, a 0, our rate, and our hours worked. And we can just do that because they're local, because we define them right here. That'll work just fine. And then in our main one here, first and foremost, we're going to say base, calling the constructor of the parent, and we are going to pass in name and age. All right, and down here, we're going to say rate equals rate. And since it's local, this rate, this is why it's confusing, and I didn't want to show you, but I'm going to show you here. This rate is local. It's this rate, not this one. So while they have the same name, if I wanted to talk about the rate that was a member of this class and not the local rate, I would have to say hourly employee rate. All right, or I'm sorry, that's C++. Our employee, or here I'm stuck in my C++ syntax. This dot rate, yep, equals rate. I can do that, and so this rate here is our local rate that we're reading in. This rate here is the rate that belongs to the class. All right, I know it's confusing. That's why I was not going to show you, but I thought, well, hell, I'll just expose you to it, and if it confuses you, think on it a little bit. It shouldn't be too bad, but when I do this rate equals rate, that's going to work out fine. We're using this local rate and then our property, which sets our member rate. All right, and then we are going to do hours worked equals hours worked. All right, so great. Our constructors are set up. That all looks fantastic. Let's give her some extra spacing here. I need to create my pay, so I'm going to do public double calculate pay. In this class is simply going to return hours worked times rate. Now, this is something I see a lot with student work and stuff like that. They want to have some private double pay. And what they do inside the constructor, they say rate or pay equals rate times hours worked. And they think, hey, now pay is accurate. Great. I'm assuring you this is not a good idea. All right? Never store pay like this. The way I like to break it down is this. Can you define what pay is without talking about other variables? You can't. What is the pay? Well, the pay is the rate times the hours worked. That's what the pay is how much you're being paid. All right, can I talk about the rate without mentioning other variables? Yes. The rate is the hours worked. It is no other variables rely on it. It does not rely on other variables. All right? So I store rate. I don't store pay. All right? Because what happens is this. What happens if I create my object, passing in an hours worked and their pay rate, and so I calculate how much money they get, and then I think, oh, you know what? They worked overtime. I forgot to add 2 more hours. All right? So that you use their set method, all right, to set their hours to higher, and then when you calculate pay, if you just return pay, their pay is wrong. All right? Because you didn't recalculate it. All right? So don't store values like that. If you can't define a variable without talking about other variables, that variable should not be there. I can't talk about pay without saying that pay is the rate times the hours worked. So pay doesn't exist. The pay is just another way of looking at these two variables. If you're talking about, like, say, the area of a triangle, never store the area. Why? Because the area is nothing but the length times the width. All right, divided by 2 in the case of a triangle, right? The area is nothing on its own. It's the length times the width. All right, so we don't store that. So here we're not going to store pay. We're just going to calculate the pay and return it here. Finally, I'm going to say public string to string, and I forgot the override again. And in here, I'm simply going to return base.toString plus, and let's see, also hours worked. Here, I'm going to do this because this will be easier. String.format. Also, hours worked is or are. Also, I worked, because I don't know if is or are is the right thing. 0 hours, and I get paid dollars per hour. Awesome. Okay, we'll go ahead and save that. Let me just build it. Build's great. Fantastic. So now I have my 3 classes. So in my program here, I'm going to go ahead and get rid of this. And I'm going to say hourly employee. My hour emp equals new hourly employee. And we're going to pass in the name, Mike, age 30. And my rate, let's say I make $10 an hour. All right, and let's say I worked 42 hours. All right, and then we're going to do a console dot write line, and we will say my hour emp dot calculate pay, and then we'll do a console dot write line my hour emp dot toString, and we'll run it. Oh, hey, and I have a crash. Where did I crash? I'll use this as a great chance to show you some debugging here. I believe I crashed in the toString method here. So I'm going to put a breakpoint right there, and I'm going to run it again. We get to my breakpoint without it crashing, so I know the crash is after this breakpoint. So I'm going to go ahead and step over, and I get my crash. Index 0 base must be greater. Oh, I never put the variables in there. See? And here we go. So debugging helps save us a little bit. I use the 0 and the 1, but I never specify what goes in there. So whoopsie. So I have to specify hours worked and rate. Whoops. Okay, great. So even I make mistakes. There you go. And I'm going to go ahead and open this up. I'm going to see that my pay is $420, and my name is Mike. We can tell that that's right because 10 times 42 is 420. My age is 30. You can see here I have a little bit of a, what do I want to say, a text snafu. Let's fix that real quick there. I'm going to say period space, and then I'll run it again. Oops, there we go. And I'll say also I worked 42 hours and I get paid $10 per hour. Awesome, our classes work. We have our children class, which inherit from our parent class or superclass or base class or whatever terminology you choose to use. Um, and that works out quite fine. All right, so that's going to conclude this video on inheritance. Hopefully you can see kind of the syntax and how the inheritance works in C#. That becomes important because we use inheritance a lot in Windows programming. And yeah, so in the next video, we are going to take a quick look at composition followed by polymorphism.